so Algebra 1, 5.4, we're just continuing to do things with inequalities. There's really not one new thing today. It's just a matter of putting together the two previous things we did. So adding and subtracting, we did some opposites, we left the sign alone. Yesterday we multiplied and divided, and on half the time we would turn the graders into lesses or lesses into graders. The deal on that was the negative had to be multiplying or dividing with the variable that caused the sign turn. Those two things are still in effect today, as well as just other things we've done before. So what's back a little bit more in today's homework, just to make the problems a little bit bigger, they're multi-steps. A lot of yesterday's was just one step, multiply or divide. 2 days ago, a lot of them were just one step, add or subtract. Today there's a lot of two-step questions. There's also some that involve other things. So of our other things, priority 1, if you see it, is distribute. So when we take this problem on, the first thing you'd want to do is distribute before you do anything else. Priority 2 in our old days would be if you see two variables, if they're on the same side of the sign, you'd want to combine them. If they're on different sides of the sign, we'd want to pick one to eliminate. That would be priority 2, after distributing being priority 1. When we reach that point, then we're always going to add or subtract somewhere toward the middle-ish of the problem. Adding and subtracting is our first opposite when it's time to do opposites that we'll want to do, and save the multiply or divide for last. And I don't know if any of the questions today will divide. I think they might all be set up to be multiply on the board and therefore divide in your world when you go and do the opposite. This one's not too long. Okay, this is about as short as they'll get for the today problems. There's just two opposites to do. There's nothing to get this ready to go. It's just ready to go. Do our opposites. So we'd want to add 7. When we go to add and subtract, the sign, the greater than sign, never will change. So we're leaving 5x alone. We're adding 7. Adding, always leave this alone. If we add 7 to this, be careful of your add rules. That'll work out to be negative 15. Now that it's time to multiply and divide, sometimes this sign is going to turn. We want the x alone. There are negatives around, okay, but the negative's not with the x, so we're not going to turn the sign. When we divide these, they're different signs, so negative dividing gets us a 3. Again, as it's been all the answers of this chapter, we need not just a number, but we need an x. We need the greater or less or some other symbol, and a number. The number alone isn't enough. This is a much bigger one. This is probably the biggest one on the board, so I'm not sure why when I made this lesson and did these notes I put this second, because it might scare people being the second problem, but it's the biggest one on the board. So if you can do this one, you can do anything because it's nothing bigger than this. We're going to start off distributing. So negative 5 multiplies x. Negative 5 multiplies negative 2. Negative times negative is positive. 5 times 2 is 10. Still a minus 4x, still a less than, still an 8. Now we have a couple variables, so we'll combine like terms because they're on the same side. This and this are on the same side of the symbol, so we're going to combine them. Always add rules when we combine. 2 negatives makes a negative, and we add them to get negative 9x plus 10 less than an 8. There's no chance of you turning this sign as you distribute or combine. The only thing that can turn that sign will be the last step of the problem when we divide. So it's time for us to add or subtract opposite. Since this is adding 10, we'll subtract 10 to eliminate this. When we subtract 10, 8 subtracting 10 would take us into the negatives for 2. And the negative 9x still sits and waits. And now at the final step, when we get the x alone, maybe sometimes, half the time, it'll be time to turn the sign. And in this case, yes. Since there is a negative with the x, that's going to turn the sign from lesser into greater. Dividing 2 negatives makes a positive. 2 dividing 9 is best written as the fraction 2 dividing 9. This one's a little smaller, but it's a thing we didn't do today, but we've done this a good bit before. There's no distributing, which is our number 1 look. No, never mind. There's nothing new about this today. We did this already. There's 2 x's, and they're on the same side. For a moment, I was thinking those x's were on different sides, and we hadn't done that today. But no, this is just a combined problem. Negative 7 combining with positive 3 is negative 4x. Copying plus 8, copying the sign, copying the 1, none of that changes. Then when we do opposites, it's always adding or subtracting for the first opposite. To get rid of an add 8, you'll subtract 8. If we subtract 8, those things just copy. The sign just copies. And subtracting 8 from 1 goes negative. Finally, at the last step, it'll always be time to think about when we get to x alone as the last step, do we need to turn the sign? And in this case, yes. There's negatives everywhere, but this is the one that makes our greater turn into a less because it's with the variable. Negative dividing negative is positive. 7 dividing 4 is best written as 7 dividing 4. This is a distribute question, so we're going to do the distribute first. The old shortcut from days gone by could still be used, by the way. We had a shortcut where instead of distributing a 2, we could divide 2 into the other number. If you like that trick, that could still be done, just not on this problem, because 2 doesn't go into 7 very well. But if this were like an 8, you could divide by this negative 2. That, though, would turn the sign at the beginning instead of the end. If you do the shortcut, it sort of changed when that would occur. So if you don't know what I mean by the shortcut, forget the last 30 seconds of what I said. But if you used to like that shortcut, it still can happen, even in the inequality world. It just might involve a sign turn when you do the shortcut. Distribute here, we get a negative 6x plus an 8 if we distribute. And then we'll start doing opposites. To get rid of the add 8, we'll subtract 8. So negative 6x waits its turn. If you subtract 8 from something that's already negative, we go way down the negative scale to negative 15. And then it's time to get the x alone, and maybe it's time to turn the sign. And in this case, yes it is. Since the negative's with the x, we'll turn the sign. Negative dividing negative is positive. If we put 15 on top of 6, that's decent, but that's a reducible fraction. 15 on top of 6 should reduce to 5/2. Reduce it by dividing 3. For this one, we want to not attack this 2/3 first because it's multiplying. We want to attack the 8. The 8's got to go as our first opposite. Get rid of that. Don't worry about this minus having anything to do with the 8. It doesn't. This minus is stuck on that fraction. We're trying to get rid of a positive 8. To get rid of a positive 8, we'd have to subtract 8. So this negative 2/3 x can wait. If we subtract 8 from something that's already negative, we're going to get a bigger negative down to negative 12. And when we go to get the x alone at the last step, maybe it's time to turn the sign around. And in this case, it is. There's a negative with the x. It's time to turn the sign. 2 negatives when we divide is positive. Fractions when we divide, they flip. That's over a 1. A little bit of a cancel. And we should get 18 out of that. Decimals, no real difference. You do the same stuff, you just have to live with the decimals. So the multiplying part we'll leave alone. The sign we leave alone. To get rid of a subtract 2, we have to add 2. If we add 2 to 0.8, that's 2.8. To get the x alone, this is where we sometimes have to turn the sign, but not here. There's no negatives anywhere in this problem. So that's just all positive all the way. Leave the sign alone. We're going to divide by 0.7. So we could either go 0.7 out of the box and do our normal kind of division to get a 4. Or you could do the 2.8 on the 0.7 and do that little bit of a slide. You can still divide and get 4. And then the last one of the day, here's what I thought I had earlier and didn't. Here there's a variable on each side of the equals. With a variable on each side of the equals, you've got to get rid of one. If you want to get rid of a positive thing, you subtract it. But we usually prefer to get rid of the negative item by adding it, because that just keeps our life a little simpler. If we add 4x, we stay positive and go up to 9x. And if we stay positive, that spares us the ordeal of maybe returning the sign. There's not a sign turn on this, because we stayed positive. So this sign, it's locked in all the way to the finish line. We're going to copy the 9x and add the 3. To get rid of a subtract 3, we've got to add 3. And then to get this all the way alone, divide by 9. 33 on top of 9 is pretty good, but that also reduces by 3s like one we had a second ago. So that'll be 11 over 3, and that's what we're doing. So upcoming stuff, homework off of this is page 200 from 1 to 22, plus 34, plus 41, plus 42. If you missed that, rewind it or grab your syllabus to work from page 200. That will be due next class. Then I already gave you the review sheet, the practice quiz from 5.1 to 4. That would be due the next time we see each other in person. When we see each other in person, the practice quiz would be due. Yes, I'm correct. So practice quiz would be due next time I see you. We'll do that review. We would take a quiz early in the next week.